Assalamu alaikum warahmatullahi wabarakatuh. In physics, we were doing the lesson kinematics of the linear motion. Let's review. We have studied about the two types of quantities in physics, scalars and vectors. We studied that the scalars are represented by a single number that represents the measurement, any measurement it could be, while the vectors are represented by a number of measurement that is telling the magnitude along with a direction. The scalars are always positive, while a vector could be positive or negative, and it can also be plotted on a graph. The scalars follow basic rules of algebraic calculations. To calculate a vector quantity, vector algebra is used. Now, if I have to go from home to school, the total path I cover between 2 points is the distance moved. It's a scalar quantity because it has no direction, while a straight line distance between any 2 points is the displacement, and because it has a direction from the starting point to the ending point. So it's a vector quantity. The speedometer of my car, it shows the distance I traveled in the time which is taken. So that's what is my speed. The speed is a scalar quantity and it is represented as v, which is equal to capital S distance divided by time, t. When equal distances are covered in equal intervals of time, it has a uniform speed. Speed is not changing, so the needle of the speedometer will remain at the same point. So the body is going to have the uniform speed. It means if the speed is changing, it is variable. Now we have an example from the book. A motorcycle covers about 150 meters in 10 seconds. So S distance is 150 meters and it is traveled in time 10 seconds, and we have to find out the speed of the motorcycle. So putting the formula V is equal to S upon T, we will be having 150 upon 10, and that's equal to 15 meters per second. Meter per second is the derived unit for speed. The velocity. Velocity again is a vector quantity. It refers to both the speed and the direction of the motion. It means the speed is only concerned with a value, a magnitude, so it's a scalar, and velocity has both, so it's a vector. Velocity is also denoted by v, but it has an arrow on it, and the displacement over here, which is denoted by ray over the s, so that's different from the distance. Velocity is equal to displacement in the unit time. When speed and direction of the motion of a body both remain the same, it has uniform velocity. But if any one of the two remains the same and the other one changes, the body will possess a variable velocity. Like if it is travel in a straight path but the speed is changing, the velocity will be variable. Similarly, if the body is moving in a circular path, so the direction is changing with the same speed, it will again be a variable velocity. When the velocity changes, we get a new quantity. The change in the velocity is called acceleration. The change of velocity in the unit time is represented as delta v upon delta t. The delta v, that is the change in the velocity, is equal to the final velocity minus initial velocity. So the rate of the change of velocity, that is delta v upon delta t, is equal to a, the acceleration.